Good morning, everybody. Hope you are all healthy and safe at home. We are going to continue with our section on surface integrals, section 9.13, surface integrals. In this lecture, what we are going to discuss is about a new term called the flux. Okay, so let's move on to the definition of flux. Now, if F is equal to Pi plus Qj plus Rk is a velocity field of a fluid, then the total volume of a fluid passing through the surface S per unit time is called the flux of F through S. Okay, so flux is actually the volume of fluid passing through the surface per unit time, and it is given by flux is equal to double integral over S F dot n ds, where n is the unit normal corresponding to the particular surface. So this is how the definition of flux goes by. So just remember, flux is the double integral over S F dot n ds, where n is the unit normal and we know ds is the differential of the surface area. We have done in the previous lectures. Now there is one thing that you can note, that is, if the surface is closed, then and the corresponding, if we have a closed surface and if n is the outward normal, okay, n is a normal which is pointing outward or correspondingly inward, then the equation of flux gives the volume of fluid. If it is outward normal, it gives the flux gives the volume of fluid flowing out of the surface, and if it is inward, it gives the volume of fluid flowing inside or in through the surface per unit time. So the flux actually gives the total volume of the fluid passing through the surface, and whether it is inside or outside the surface depends upon the unit normal. If the unit normal is outward, then the fluid flow is outward through the surface, and if it is inward, then the fluid flow is inward through the surface per unit time. So that's it. We have a very short lecture today. That's the definition of flux and how it is related to the double integral, and we shall do an example in the next lecture. So that's it. Thank you. Stay home and stay safe.